solar panel. Ay, anong gagawin mo dyan? Check natin yung voltahe niya. Gamitan natin ng tester. Set natin sa DC. Okay. Breadboard. USB. Tutukan natin ang ilaw. 5 volts. 5.16. Diba? Takpan natin. Halos wala na, diba? 0.8. Meron tayo dito, solar panel LED. Pag may ilaw, ayun meron ding ilaw yung LED. Pag tinakpan mo, nawawala. Diba? Okay, iba naman ito. Meron tayo ditong solar panel, battery, 18650 LED, diode, transistor, at resistor. Pag may ilaw, walang ilaw yung LED. Pag walang ilaw, yun takpan mo, may ilaw yung LED. Yan ang ating solar charger controller using transistor. So during the with light, nagcha-charge yung battery. At pag wala namang ilaw, yung battery ang nagsusupply doon sa LED. We have now this figure solar charger controller using transistor. So this is DC solar panel, 5.5 volts. As indicated here, it is 5.5 volts. And then we have this 18650 battery, 3.7 volts, rechargeable battery. And then we have the LED module, already with the resistor and then the LED. Of course, we have the transistor and then the biasing resistor, in order not to damage the transistor. So what we have here is the solar panel, 5.5 volts. What happened if we, and of course we have this diode, fast switching diode, 1N4148. What happened if there's a light, okay, or a sunlight, or a table lamp, or a light? If we have the light, this solar panel will serve as a supply, okay, with a voltage of 5.5 volts. And in our figure, we have the battery, 3.7 volts. So there is a potential difference between the two. Supply, a battery with 3.7 volts and a solar panel with 5.5 volts. So if there's a potential difference, what will happen is it will charge the battery, because the solar panel voltage is greater than the battery. So when we are going to use any solar panel, it must be greater than the battery voltage, so it will charge the battery when there is a light or a sunlight into the solar, and then the current flows into the D1 back to the solar panel, charging it, bypassing this transistor. In order to turn on the LED, we need at least 0.7 volts to the base emitter of this transistor. Or at least we have a triggering current to the base of the transistor. So the purpose of transistor is act as a switch. So whenever there is no light, now or during the nighttime, there's no sunlight, the battery now will serve as a supply, and then current flows into the solar panel. It will now serve as a load or a small resistance flowing into the solar panel, act as a load, and then current flows into the base of the transistor, triggering this transistor to switch on. So it will switch on and then flows back into the negative side of the battery. It will close, triggering the transistor to switch on. And now, also, when there is a voltage now developed across base to emitter at least 0.7 volts, the current now flows into the LED resistor. We need this in order not to damage the LED, and then collector to emitter, then to the ground. So the LED turns on whenever there is a triggering current to the transistor. Current also flows into the output side of the transistor. So the LED turns on because the current now flows from LED to the collector to emitter and then back to the negative. As long as there is no light that falls into the solar panel. So what is the purpose of this diode? This serves as it separates the negative of the voltage of the battery to the negative side of the solar panel. Okay? That is the purpose of the diode. So that's why whenever there is a light or sunlight to the solar panel, this is now we're going to charge the battery. When there's no light, it will serve as a load. And now this one is the one supplying the current to the transistor, and therefore this LED turns on.